Hi everyone, good evening. Welcome to Manorama Horizon revision classes. Can you hear me? Okay. Is the slides moving? Okay. So let's start. So today we will be discussing the second chapter, acids, bases and salts. Okay. Here in this chapter, we will see the different properties of acids and bases and the different factors that acids and bases have in common and chemical properties of acids and bases. Then we will see how the salts are forming and we'll be dealing with the strength of acids and bases. Okay. So how we can differentiate acids and bases? We have seen acids and bases in our daily life, right? What all things we are seeing in our kitchen, we are seeing in our labs. So all contains different types of compounds. Some may be acids, some may be bases. So it goes that way. So we will see how we will differentiate acids and bases. So we will differentiate acids based on certain substances known as indicators. Okay. So we'll classify indicators based on their nature. So we will classify indicators into natural, synthetic, and olfactory. So natural indicators, we have examples, turmeric, litmus, etc. For synthetic indicators, we have methyl orange, phenolphthalein, etc. Olfactory means onion, then clove oil, then vanilla extract, all will come in olfactory indicators. So we can differentiate acids and bases using indicators. So there are different types of indicators. We saw the examples as well. So next, how that indicators will change in acids and bases, that we will see now. So turmeric, its original color is yellow. In acid, there is no change. In base, it will change to reddish brown. So if some curry or something is spilled on our clothes, so first initially it will be yellow color. After some time, if we are adding soap or something, it will become reddish brown. We have noticed this change, right? So that is how indicator work. So actually, oil is containing the turmeric. Like if we are adding turmeric in curry and all, that oil may contain turmeric. After we are applying base, it will become reddish brown. This is the change that happening in turmeric. So litmus. So litmus are of two types, red and blue. If we are using red color litmus, in acids it will not change. In bases it will change to blue color. So then blue litmus will change red color in acids and there will not be any color change for base solutions. Then methyl orange. Methyl orange original color is orange and it will turn red in acid solution and yellow in base solutions. Phenolphthalein is another indicator whose original color is colorless. It's actually like liquid water only. So it will be colorless in acids, but it will turn pink in base solutions. Onion. Onion is having a distinct smell, right? We know it. And in acids, there will not be any change for that smell. For base, that smell vanishes. So we'll see now some of the properties of acids. Acids have a sour taste. Okay, that is the important property that we are studying from lower classes itself. Then acid turns blue litmus red. Then acid solutions conduct electricity. So the conduction of electricity is due to the presence of H plus ions. Okay. So H plus ions are abundant in acid solutions. That's why acids conduct electricity. We'll see some of the examples of acids. Examples include sulfuric acid, acetic acid, nitric acid, etc. So we are going a bit fast. It's because last class, actually we took a 1.5 hour time. So we don't have that much time to spend. After this, you have classes, right? From 7 o'clock onwards. So we'll go a bit fast. If you feel any doubts in between, you can ask. Okay. So you can ask in chat box. So acids can be classified into two types based on their nature, that is natural acids and mineral acids. So natural acids include methanoic acid, acetic acid, oxalic acid that we will get from nature. Then mineral acids that we are preparing, this mineral acids, example hydrochloric acid, sulfuric acid, nitric acid, carbonic acid, and phosphoric acid. These are some of the examples of mineral acids. So with the names, you have to note down the chemical name of the acids as well, like chemical symbols. So again, we can classify acids based on their strength into strong acids and weak acids. Strong acids include hydrochloric acid, sulfuric acid, nitric acid, etc. Weak acid, acetic acid, carbonic acid, benzoic acid. All these are weak acids. Okay. So now we saw the different classifications of acids and properties of acids also we have discussed. Now coming to chemical properties of acids. So first is the reaction of acids with metal. We have already studied this one in last class, also in lower classes as well. So what will happen when acids react with metal? When acid react with metal, it liberates hydrogen gas. Okay, we'll get a salt, metal salt. In addition to that, hydrogen gas is produced. So metal react with acids form salt and hydrogen. We'll have examples for zinc and sodium. Zinc react with HCl forming zinc chloride and hydrogen gas. Similarly, sodium react with the sulfuric acid forming sodium sulfate and hydrogen gas. Okay. So next is the chemical properties of acids. First, we saw that reaction of acid with metal. Here, we told it produces hydrogen gas. Okay, how we will test the hydrogen gas produced? Okay, if you are bringing a lighted candle near the gas evolved, it burns with a pop sound. Then we can confirm that the gas formed is hydrogen gas. Okay, so this is the way how we will confirm that the hydrogen gas is produced. Okay, this was the first property that we discussed, reaction of acid with metals. So the reaction of acid with metals produce hydrogen gas. So next is the reaction of acid with metal carbonate. I think still our students are joining only. Shall we wait for a minute or so? Okay, we'll wait for a minute. Actually, today we are going so quickly, so we'll wait for a minute. Okay. Till 6:10. Okay, now it's 6:10. 6:11 we will wait for a minute. You can tell your friends like this class is going live stream on YouTube. They can also watch from YouTube as well. So you can inform your friends about the class. If someone is yet to join, tell them to join quickly. Okay, we'll wait for 1 minute. Actually, we should do this at the beginning of the class. Okay. Okay, rest who were here in the class, you can see from beginning. If there are any doubts for you, you can ask this time. Okay, you can use wisely this time to ask any doubts. If you want any explanations in Malayalam, then you can tell me at the end of the class. Like during the doubt session, you can ask me. That time I will explain in Malayalam if you want. Okay. Okay. So Fatima has asked a question like how acids are divided. So we'll go back. So we have seen the characteristics of acids. Okay, acids having sour taste. This one we know. It will turn blue litmus into red. Acid solution conduct electricity. Why it conduct electricity? Because of the presence of a large number of ions in aqueous solution. So that's why acids conduct electricity. So we have seen the different examples also. Sulfuric acid, acetic acid, nitric acid, etc. are examples for acids. So acids can be divided into two types based on their nature, how they react or how they act. So based on the nature, we can divide acids into two types, natural acids and mineral acids. Okay, so natural acids we will get from nature, or that source is carbon compounds. So we'll get, we have methanoic acid, acetic acid, oxalic acid. Methanoic acid, then acetic acid is ethanoic acid. So oxalic acid, these are all natural acids. These are derived from carbon compounds. We can see that, no? So these natural acids are weak acids. We can say that these are not having that much strength. But if we are considering mineral acids, they are strong acids. Okay. So hydrochloric acid, sulfuric acid, nitric acid, carbonic acid, phosphoric acid, all these are mineral acids. So comparing to these natural acids, the mineral acids are strong acids. Okay. So again, we can classify acids into two types, strong and weak acids. This natural and mineral acids, we are dividing acids roughly, and oftenly, more solely, we are dividing acids into strong acids and weak acids. Okay. So strong acids include hydrochloric acid, sulfuric acid, nitric acid, etc. In weak acids, we have acetic acid, carbonic acid, benzoic acid, etc. So these all comes in weak acids. So base is carbon. Carbon-based acids are weak acids compared to strong acids, okay, mineral acids. So is it understood? Okay. So coming to chemical properties, we will start with reaction of metal with acid. So acids react with metals forming metal, salt, and hydrogen, we told. So metal, when reacting with acid, we will get salt and hydrogen. Zinc reacts with HCl, giving zinc chloride and hydrogen. Zinc chloride is a salt formed. Okay, here zinc chloride is a salt. Okay, zinc chloride is a salt. Similarly, sodium reacts with the sulfuric acid, forming sodium sulfate. Na2SO4, that is a salt. This is a salt. And hydrogen is forming. Okay, in two places we can see hydrogen is forming. So whenever acids react with metal, we will get hydrogen gas. So now we will see like how we will check whether the gas formed is hydrogen or not. So we'll bring a lighted candle near the gas evolved. If the gas burns with a pop sound, then it confirms the evolution of hydrogen gas. Then second chemical property. Second property is that reaction of acids with metal carbonates. So metal carbonates are compounds having this group CO3 2-. So Na2CO3, that is metal carbonate. Here we are having sodium. We know that sodium is a metal. Okay. So a sodium is a metal and carbonate group is there, CO3 2 minus. So this is carbonate group. So metal carbonate, sodium carbonate. Metal carbonate react with HCl. HCl will get sodium chloride. Sodium chloride is a salt. Okay, metal salt. Actually, salts are formed by chlorides, fluorides. So these anions forms salt. Cl minus, F minus, bromides are there, Br minus. So this class of compounds will call them as salt, sodium chloride. Plus we'll get carbon dioxide in addition to that and hydrogen. So metal carbonate react with acid forming salt, carbon dioxide and water. So remember this one, we'll get carbon dioxide gas when metal carbonate reacts with acids. So acids react with metals, we'll get hydrogen. If it is metal carbonate, that is carbon dioxide. So then a reaction of acid with hydrogen carbonate. Okay. We saw that this valence is CO3 2 minus. Okay. CO3 2 minus. It is having two negative ions, right? If one of the negative ion is satisfied by hydrogen, then we will call it as hydrogen carbonate, metal hydrogen carbonate. Okay. So this metal hydrogen carbonate react with acid. Here we took sulfuric acid. The metal hydrogen carbonate react with the sulfuric acid forming sodium sulfate plus carbon dioxide plus water. So sodium sulfate is again salt. This is salt. Sodium sulfate is salt plus carbon dioxide plus water. Any doubts in this? Okay. Okay. So we saw the different properties of acids. So three properties we have seen: reaction of metals with the acids, then acids with the metal carbonates and metal hydrogen carbonates. So if acid is reacting with metal, we will get hydrogen. If it is with metal hydrogen carbonate or metal carbonate, it is carbon dioxide. Okay. Previous slide. Previous slide means I think this one, chemical properties of acids. Okay, this is hydrogen carbonate. Joseph and O. Are you mentioning this slide or the previous one? This one. Okay, this one, right? Reaction of acids with metal carbonates. Do you have any doubts over here? Here, what happens is acids react with metal carbonate. Okay, so metal carbonates are compounds having metal and carbonate. Here, metal is sodium and carbonate CO3 2 minus. Okay, 2 minus 2 negative ion valences are there now. So we will satisfy with 2 positive, Na2. So what happens if, okay, sodium carbonate, we will substitute with HCl. So what will happen? This sodium carbonate, we will get the same salt. Okay, I'll write the equation. Na2, CO3, aqueous, plus HCl with H2SO4. Okay. We are substituting with H2SO4. Okay. H2SO4. That is also aqueous because acid solution we will take in water only. So that's aqueous. We will get sodium sulfate. Okay, so instead of sodium carbonate, it will be sodium sulfate salt, Na2SO4, aqueous, plus same we will get carbon dioxide, CO2 gas, plus H2O liquid. Wait. Na2SO4 plus H2O. Okay, so sodium carbonate react with the sulfuric acid. Okay, here that anion coming as sulfate. So this sulfate will go with sodium. So Na is having valency 1. So compound will be Na2SO4 aqueous. Then from this carbonate, CO2 will go. Okay, it will decompose to CO2. Then 2 hydrogen is there now. 1 H2O. This will be the reaction. Understood? Okay. So now we will see the chemical properties of bases. Okay. Now we will see the chemical properties of bases. Okay. So bases have a bitter taste. This we all know. It is soapy in touch and turns red litmus blue, conducts electricity in solution, and releases OH minus ions in aqueous solution. So the reason for conductivity is because of the presence of this OH minus ions. There are a lot of OH minus ions in this bases. So this bases conduct electricity. Ions will be there now. So conductivity is always due to the presence of ions in solution. Okay. Okay, we have a question here. When acids react with CO3 and HCO3, are the result the same? Salt, carbon dioxide, and water. Yes. But nature of the salt will be different. Okay. So what type of acids we are taking, based on that, it will differ. Remaining, everything will be same. Okay. If it is carbonate or bicarbonate, we will get carbon dioxide. From that carbonate only, that carbon dioxide is forming. Okay. So remaining, anyway, one proton will be there, and from that carbonate, we have one oxygen. So it will form water. Salt will be different based on different reactions. Definitely we'll get carbon dioxide and water and the salt. Okay. Yes. Both acids and bases will conduct electricity. That is the property. Because of these acids and bases are solutions, right? So in solutions, there will be having a large number of ions in solution. So based on this ions, because of these ions in solution, these acids and bases conduct electricity. Okay. Okay. So we have seen the properties of bases. We'll see next. So chemical properties of bases. Similarly, bases react with metals, forms hydrogen. Same, we will get a salt and hydrogen. Okay. Here, sodium hydroxide react with a sodium zincate plus hydrogen. We will get a salt and hydrogen. We have to consider that product hydrogen formed. Okay. Always we should consider that product formed as hydrogen. The next is reaction of base with oxides of non-metals. So non-metal oxides. What we will get? We'll get again salt and water. Bases react with non-metal oxides gives salt and water. So non-metal oxides are acidic in nature. This one we have to understand. We have to keep in mind. So metal oxides, Na2O, Na2O. So Na2O, metal oxides will be basic. Okay. Basic in nature. Similarly, non-metal oxides will be acidic in nature. Okay. So these non-metal oxides are acidic in nature. Carbon dioxide is a non-metal oxide. How? Carbon is a non-metal, we know, right? Carbon is a non-metal. So non-metal oxide. Oxides are compounds of non-metals and oxygen. Or metals and oxygen coming, it is also oxide. Any metal element plus oxygen will get some compound EO, like it may be E2O, E3O, like for example, Al2O3, or this is the oxide of aluminum. Then copper oxide will be there, zinc oxide will be there, magnesium oxide will be there. So these are all oxides. Any element having oxygen to form a compound. Oxygen as its partner to form a compound, we will call them as oxides. So this is a carbon dioxide is a non-metal oxide. Carbon is a non-metal, that's why we will call it as a non-metal oxide. So sodium hydroxide react with the carbon dioxide forming sodium carbonate. We'll get sodium carbonate, that is a salt, and water. Okay, understood? Okay. So next, neutralization reactions. We already told this neutralization reaction in double displacement. Acid react with base forming salt and water. HCl reacts with NaH forming NaCl and H2O. Here we got salt and water. So neutralization reactions are the basic reactions that bases and acids form. This we can give in acid as well, right? Acid plus base give salt and water. So the next is reaction of acids with metal oxides. Okay, we have seen what is an oxide. If the element combines with oxygen is a metal, then we'll call it as metal oxide. Okay, so we'll call them as metal oxides. So these metal oxides are basic in nature, we told. So acid react with metal oxide, we'll get salt and water. Okay, basic thing that we need to understand here is acid is reacting with a base. Metal oxide is a base. Okay, so acid is reacting with a base and forming salt and water. HCl, it is acid. See, calcium oxide is a metal oxide. You can see calcium is a metal and oxygen is the component contributed for the formation of oxide. Okay, so calcium oxide, it is a metal oxide forming calcium chloride. Calcium chloride is salt and water. We will get water. So these are the properties of bases. Do you have any doubt in this properties of bases? If no doubts in properties of bases, then we will go further. Have you understood what is metal oxides, what are non-metal oxides, everything? It's clear or not? Okay. Okay, then we will proceed. Okay. So what is meant by dilution of acid and base? Okay. So if you're taking a beaker containing 5 ml of water, 5 ml of either acid or base, think. This is a beaker. So this much acid or base we have taken. Okay, this much. Then we are adding water to it. So in usual practice, we should not do that. What we will do, we will take beaker containing water. Okay, this is water. So what we will do, we will pour acid or base to this water only. Okay, so if we are adding, let's see, suppose the volume will came till now. I'll show you clearly. So this is a beaker. This much we put water, and if you are adding base or acid to it, let totally it came like this. So when we are adding, what will happen? The number of hydrogen ions or hydroxide ions per unit volume increases. Okay, before this much was the volume. Okay, for liquids volume, how we will define volume? Volume is the shape of that container. Okay, this much was the volume. If we are adding more acid or base, what will happen? Volume increases. That's why we are saying here now. Let's see. Let's say here 1H plus, here 1H plus, 2, 3H plus were there. Okay, we will tell in this much portion before 3 hydrogen ions were there. We are telling. Okay, so if you are adding acid or base, or we will say acid. Okay, if you are adding acid, now that volume increases. So now volume, when that volume increases, this 3H plus can locate any of these region. Okay, so it is not confined to this lower portion. It can come to upper portion also. So number of hydrogen ions per unit volume will get decrease. Okay, so before what it was, when that volume increases, okay, during dilution, what will happen? Volume will get increased, but number of ions per unit volume decreases. When we are adding, there will not be any increase in the number of ions. That's why during dilution, what will happen? The number of hydrogen ions per unit volume will get decreased. Same will be the case with OH minus also. So this is the concept of dilution. Actually, we are diluting acids or bases to reduce the concentration. So that's why either if you are telling hydrogen ions plus hydrogen ions or hydroxide ions, that number of ions per unit volume will get decreased. Okay. So this addition is known as dilution. Why we are adding water, like that reverse will not happen, that I will tell you in the next slide. Okay. So the dilution of acid or base is exothermic reaction. So huge amount of heat will be liberated in such a reaction. So what will happen? We will not add acid or base to water. What we will do? We will add, we will add acid and base to water only. We will not do reverse. We will take 100 ml of acid and we will not add water to it. So the reverse only. We will take 100 ml of water and we will add 20 ml of acid or base to it. This way only we will do. We will not do reverse. Okay, dilution. Then, if the water is added to a concentrated acid or base, a lot of heat will generate. Okay, which may cause splashing or severe damage. It will cause splashing or damage. So this one we have to keep in mind when we are going to higher classes. Also, if you are doing experiments or something, some tests or so, we will not add water to acids. We reverse only. We will take water in more quantities and we will add either acid or base to it. Okay, so that's the reason. Understood? So we'll go. We'll see the strength of acids and bases. How? So we are having a pH scale ranging from 0 to 14. So in that scale, we will say the strength of acids and bases. Okay. This 0 to 7, we will tell the solutions. These are acidic, we will tell. Acidic. 7 to 14, we will call these as basic. Okay. How it is acidic? from 0 to 7 pH. 7, if it is 7, it is neutral. Okay. These values we already know. Okay. So from 7 to 0, we will tell acidic nature is increasing. So if I am telling you are giving a solution having pH 2 and pH 6, which is more acidic? 2 will be more acidic. More acidic. 2 will be more acidic. 6 will be less acidic. Okay. Similarly, if we are giving here pH 13 and pH 8, which will be more basic? pH 13 will be more basic. So this is how the pH scale works. Okay. So if it is having less pH, number of hydrogen ions will be more. That we can see here. Okay. See this shaded portion. See, shaded portion is more, na? So concentration of H plus ions will be higher here. If you are going till 14, concentration will be less. Here, concentration of OH minus will be more. Okay. That's why these are basic solutions. Is this clear? Strength of acids and bases? Okay. Examples. So that's why I have to, if you are getting a solution of pH 2, that solution is more acidic compared to a solution having pH 6. For example, we will say nitric acid. Nitric acid with pH. Nitric acid with the pH. We have taken pH, suppose it will be roughly 1 point something, it will come 1.2 or something. The same time, acetic acid will have a pH of 4.8 something. Okay. So which is more acidic? Nitric acid will be more acidic. pH value is less, right? So this nitric acid will be having more H plus. pH will be low. Okay. So that way. Like that, we can compare the strength of acids and bases. Same for bases also. For example, if you are taking KOH, it will be having pH approximately equal to 13. So, but if we are taking phosphoric acid H3PO4, it will be roughly around 10 only. So pH is low. Here, pH is higher. It means that H plus ions is less and OH minus ions will be more. Okay, understood? So we'll go. So strength of acids and bases, we are having neutral solutions pH 7, acid solutions less than 7. For basic solutions, it will be greater than 7. Okay, so this is the chart. Then universal indicator. Okay, universal indicator is a solution which shows different color over the range of pH from 1 to 14. So universal indicator will show color change for each value of pH. So we can see that in this image, it is having different colors over different pH, right? So strongly acidic means it will show some red color, orange color like that. Weakly acidic means it will come to yellow, green and all. Completely neutral means it is green, then color is changing, right? So universal indicator shows color change like this. For example, phenolphthalein is we can regarded as an universal indicator. We can use both in acidic and basic solutions. Okay, this universal indicator phenolphthalein. Okay, here we are having a question. Water contains H. Then why is H becoming less in dilution? I'll tell you. Actually, we are not telling number of hydrogen ions less. Number of hydrogen ions in unit volume. Okay, I'll draw it for you again. So this, consider this is a beaker. Okay, after dilution, okay, this is, okay, before dilution, we are having 1, 2, okay, 3 H plus ions in solution total, okay, including water or some number. We can take it as X also. Here for calculation easiness, we'll take 3 H plus ions. Okay, after dilution also, okay, we will tell after dilution how this will be. Number of ions will not change, okay. After dilution, water we are adding, but it will be in the state. Okay, I'll tell you now. Like now it is 3, right? If we are adding 10 moles means totally it will be 13. Before it was 3 only. Now it is 13. Whole 13, no? So we will consider that time. You see, this much only that volume. This hydrogen can occupy this much only. Now that if number of hydrogen after dilution, hydrogen ions numbers are increasing also, what will happen? Number of ions is not becoming less. That's why. Okay, I hope I have answered this question. Water also containing hydrogen. Water and other such hydrogen have strong covalent bonds between it and other components, but in acid or base, H plus is loose and hence split easily into ions. Actually, the number of what will happen? Okay, think of the situation. We are having a bottle of water. Okay, you are bringing a bottle of Coca-Cola. Okay, then you are adding little amount of water, 5 ml or so into what that. Okay, so there also H plus ions is there. Now that volume increased, right? So number of ions per unit volume get decrease. That way you'd think. Okay, so these are the 3 now. We have only 3 ions in solution. After dilution also number of ions is not getting changed. So Joseph is saying like water and other such hydrogen compounds have strong covalent bonds. Actually, water is having hydrogen bonds. Okay, so different types of bonds are present in water. Okay, mainly water is having hydrogen bonds. So because of that, acids and bases, it will liberate H plus and OH minus very easily. So in effect, we will have only 3 ions in solution. So the total volume means the volume occupied per unit ion is increasing. That's why during dilution, number of ions per unit volume decreases. I hope this is clear. We'll proceed. Otherwise, okay. Actually, this is the concept we need to understand. Okay. Otherwise, we will think, okay, after if we are diluting, we will think, no, water ions from water will be there. Then our acid ions will be there. Like that, we should not think. So if we are diluting, we think of that ions from acid. So if we are having 3 ions from 3 HCl are there, 3 H plus only there. If you are diluting with water also, it will not contribute. So then these 3 can occupy in that. If you are saying like per unit volume, number of ions will be reducing. Okay, so there will be lot of blank spaces now. That's why we will not consider this whole 10. It is coming to here. It will be either in different types of bonding now. For example, hydrogen bonding will be there between water molecules. So it will be, or we will study that heat of that hydration will be there. The hydration effects will be there. Then this, due to this H2O, no, it will be bonded to some other H2O molecules. So different bonds will be there. This we will study in higher classes. Okay. So as of now, dilution, we should not consider that ions from hydrogen. It will be used for some other purposes. Okay. Okay, let's proceed. So now we'll see the role of pH in everyday life. We have only 10 more minutes left. We have to complete quickly. So in digestive system, pH in our digestive system, dilute HCl helps in digestion of food. HCl, we know that it is acid. Too much if it is excess, it will cause acidity, and antacids we are using for reducing acidity. This antacids, it has already asked it is a previous year question. Okay, it has already asked in examinations. So keep in mind, we are using antacids like magnesium hydroxide. Magnesium hydroxide is otherwise known as milk of magnesia. Then sodium hydrogen carbonate, baking soda to neutralize the excess acids. So this is a question. We have to note it down. Okay. The next is the tooth decay. Tooth is basic. We know that fluorides are there. Fluorides are bases. Okay. So what will happen? This bacteria present in our mouth, it will convert sugar into acids. So what happened? Now that acids came in mouth, right? So what will happen? This bacteria will decay our teeth, which is basic. So when the pH of the acid formed in the mouth falls below 5.5, tooth decay starts. So that's why doctors are prescribing to brush the teeth twice a day. You have to keep this in mind. So next is the soil pH. Actually, we are using, or we prefer to use, pH range closer to 7 for better plant growth. If it is too alkaline or too acidic, the plant will get spoiled. Then salt. We are having different types of salt with that we will see. That we saw already how salts are formed. Salts are formed by the neutralization reaction. Salts are electrically neutral because acids and bases are combining, right? So salts are electrically neutral. They are having a pH of 7. Then sodium chloride is the most common salt. It is also known as common salt, table salt. We'll call sodium chloride as common salt or table salt. Then most of the salts are crystalline. It may be transparent or opaque. Most of the salts are soluble in water. Solution of salt conduct electricity in their molten state. In solution also it will conduct. In molten state also it will conduct electricity. That's why NaCl conducts electricity in molten and solution, but it will not conduct electricity in solid state. The salt may be salty, sour, sweet, bitter, or umami, savory. So that is the characteristics of salt. Then neutral salt or odorless. Salts can be colorless or colored. Then we can have a family of salt based on the components present in salt. If sodium and calcium are having chlorides, okay, so we can tell chlorides is a family, calcium is a family of salt, then zinc is a family of salt. Okay, so chlorides of sodium, chlorides of calcium, then chlorides of magnesium, magnesium chloride, sodium chloride, calcium chloride, these belongs to chloride family. Then calcium chloride, then calcium sulfate belongs to calcium family of salt. Then zinc chloride, zinc sulfate, etc. comes in the family of zinc family of salt. Okay, these are some classifications you need to keep in mind. Then we have neutral, acidic, and basic salt. We will see how neutral, acidic, and basic salts are formed. Okay, let's see now. So causes of formation of acidic, basic, and neutral salt. Okay, if you're taking a strong acid and a weak base, we will get an acidic salt because acid is strong, no? Weak is base. Strong acid will react with weak base quickly, and strong acid remains. Some of the strong acid will be remaining. That's why we will get an acidic salt. Same way, if you're taking strong base with weak acid, what will happen? This weak acid and strong base react quickly. So the strong base will react with weak acid all of a sudden, and strong base will be remaining. So what will happen? Basic salt will form. Then if the equally strong acid and base react, we will get a neutral salt. Okay. Then pH value. Same as pH of solutions, we have pH for salt also same. Neutral salt is having pH 7, acidic if it is less than 7, basic more than 7. Then some important compounds. There are a lot of questions that were asked from the important chemical compounds. First, we will see the common salt. A common salt is also known as common salt or table salt, then formed by the reaction of sodium hydroxide and hydrochloric acid. So it's formed by the reaction between. So first we need to study the preparation, how that compound is prepared, and the pH value is almost 7. Okay, it is formed by the reaction of sodium hydroxide and hydrochloric acid. So next is if we are doing electrolysis of this sodium chloride solution is brine. Okay, aqueous. Aqueous NaCl. So we will get hydrolysis, 3 hydrolysis product: hydrogen gas, chlorine gas, and sodium hydroxide, and their uses. So we have to keep in mind this electrolysis product. Electrolysis of an NaCl gives hydrogen gas, chlorine gas, and sodium hydroxide. This reaction we will see later in the same class itself. Here it is. So this process is known as chloralkali process. NaCl. So NaCl reacts with water, forming NaOH and NaOH, Cl2 and H2. Okay. Sodium hydroxide. So this is the way of preparing sodium hydroxide. So our next product is sodium hydroxide. So that is another salt. So NaCl, we are doing electrolysis, we'll get sodium hydroxide. Okay, sodium hydroxide is a strong base. It is also known as caustic soda, obtained by the electrolytic decomposition of solution of sodium chloride. So that is known as brine. Okay. So then next is a bleaching powder. There are from this bleaching powder also a lot of questions were asked. So you have to know how bleaching powder is formed. Okay. So when calcium hydroxide, like a lime, reacts with chlorine, here it is aqueous now. So if the quantity of water is less, calcium hydroxide is solid in state. Okay. This also we have to keep in mind. Here it is dissolved in water, so it's aqueous. So when calcium hydroxide reacts with chlorine, it gives calcium oxychloride, that is bleaching powder. Calcium oxychloride. So this is a formula for bleaching powder, very, very important. You have to understand this. Okay. And water is formed. So it's also called chloride of lime. This name also very, very important. Chloride of lime. Bleaching powder, it's also known as chloride of lime. And how we can prepare this one. Okay. So then next is the baking soda. Baking soda is also obtained by using byproducts of chloralkali process. Chemical name of baking soda is sodium hydrogen carbonate or sodium bicarbonate. Okay. So 2 hydrogen are there. Hydrogen is there. That's why it's known as bicarbonate. It is there, no? That's why it's called bicarbonate. Then bread soda, other names. There are some other names of baking soda. So this just read out. That's it. Then preparation method, which is very, very important. NaCl reacts with water in presence of carbon dioxide and ammonia, forms ammonium chloride and sodium hydrogen carbonate. This process is known as Solvay process. Very, very important. You will get sure question out of this. So in this process, we'll use calcium carbonate as a source of carbon dioxide. If we are adding calcium carbonate instead of carbon dioxide also, we'll get the same reaction. Okay. So we will see now some of the properties of sodium bicarbonate. It's a white crystalline solid. It appears as fine powder. It's amphoteric in nature, is sparingly soluble in water. Thermal decomposition gives baking soda. Okay, Na2CO3. So this is baking soda. When baking soda is heated, so sodium bicarbonate. We can relate this name. No, bicarbonate is baking soda. We'll get washing soda. This is washing soda. So baking B is there, no? Sodium bicarbonate, baking soda. So like that we can relate. When baking soda is heated, it decomposes into sodium carbonate, carbon dioxide and water. Sodium carbonate is known as washing soda. Next, we will see the properties of sodium bicarbonate. So this sodium carbonate gives sodium oxide plus carbon dioxide. This reaction is known as decarbonation reaction because carbon dioxide is liberating, right? So in a reaction, if the carbon dioxide is getting released, that reaction is known as decarbonation reaction. Carbon dioxide is removing, right? So uses of baking soda. Making baking powder. Baking powder is having some sort of acid also in it. Okay, so this baking soda, this question is already asked, and also it is using as an antacid. So this is also already asked. It is also used in toothpaste, which makes the teeth white and plaque free. Then cleansing ornaments made of silver. Then sodium hydrogen carbonate gives carbon dioxide and sodium oxide on strong heating. Thus, it is used as a fire extinguisher. This question also asked. So, these are the uses of baking soda. Explaining all the uses, it is not possible in 1 hour. Hope you can understand that uses and all you have to study. Okay. Then baking powder. Baking powder produces carbon dioxide and heating. So it is used in cooking to make batter spongy. So we are using baking powder, right? So chemical formula of baking powder is Na2C4H4O6. So sodium hydrogen carbonate, if you are heating sodium carbonate, we will get plus carbon dioxide plus hydrogen. Sodium bicarbonate. So baking powder is a mixture of baking soda and mild edible oil. Here we took tartaric acid. Tartaric acid is a weak acid. Okay, that's why we took that one. So we can prepare baking powder out of baking soda and tartaric acid. This is the formula for that baking powder. So next, washing soda. Washing soda is sodium carbonate. Thermal decomposition of sodium hydrogen carbonate obtained by solvay process. Okay. Sodium bicarbonate, carbon dioxide, water plus sodium carbonate. Washing soda, we already saw the preparation. So same way. So this question also asked sodium carbonate anhydrous. So washing soda is obtained by the rehydration of anhydrous sodium carbonate. We will add water to sodium carbonate, then we will get washing soda. Okay, sodium carbonate 10H2O. So this 10 number, no, this 10 is the number of water molecules along with 1 unit mass of sodium carbonate. That's why this 10 is called water of crystallization. You can read out the uses of sodium hydrogen carbonate, sodium carbonate by yourself. Then water of crystallization we saw. For washing soda, it was 10. Similarly, we will see copper sulfate. Copper sulfate, it is 5. Water of crystallization, it is 5. Okay. So CuSO4 5H2O. This 5 is known as water of crystallization. Number of water molecules per unit formula mass of a substance. That is water of crystallization. So we'll have a question here. Okay, a chemical compound having the smell of chlorine used to remove the yellowness of cloth in the laundries, which will be, that will be our bleaching powder. So we have to know the chemical formula of bleaching powder and this equation to form bleaching powder. So this is already asked question. Then how is chloride of lime chemically different from calcium chloride? Chloride of lime is bleaching powder. Calcium chloride is CaCl2. Okay. So that thing we have to understand. So if you are exposing, what will happen? This chlorine will go from bleaching powder. Okay. And we will get calcium carbonate. Okay. So this is the answer. So what is the action of red litmus on dry ammonia? It is not having any action on dry ammonia. Red litmus, solution of ammonia gas in water. So solution of ammonia gas in water will be basic in nature. So red litmus, what will happen? Red litmus will change blue in basic solution. So similarly, we can have state the observations when you would make on adding ammonium hydroxide to aqueous solution of ferrous sulfate, aluminum chloride. So we will see the reactions. Ammonium hydroxide react with the FeSO4, we'll get a green precipitate of ferrous hydroxide, and in the case of aluminum chloride, it is aluminum hydroxide. Then calcium carbonate, quicklime and slaked lime. Moisture from which one will be used for removing moisture from ammonia gas? Which one will be? It will be quicklime, calcium oxide. So it is a dehydrating agent. Okay. Remaining other two compounds, no, calcium carbonate and slaked lime will react with the ammonia, forming different types of compounds. So this quicklime will absorb water. It will not react with the ammonia. Okay, now tell me if you have any doubts, you can tell me. Okay, if you are having any doubts over here. Or else you can quote any doubts over here for the next class. Friday we will be having a class. 6th October will be meeting again. That time you can ask the doubts. Okay. Now, as of now, is it fine? Like we were going in a hurry, like we need to cover almost all topics in this short hour, right? It's just like revision. We have already discussed and it's just like revision. And that's why it went bit fast. So if you have any doubts, you can ask me now, or you can ask me on Friday. We'll be meeting from 7 to 8. That time we will be having time. 7 to 8, right? Is it okay? Shall we wind up? Okay. Okay. Then thank you all. Thank you so much.